Hi, welcome to another lecture of GS Yatra. In this video, we are going to design a poll widget. The level of this question is easy, so without wasting any time, let's get started. What a widget basically is, widget is something that is created once, used by many. For example, if we take a like button of the Facebook, so they provide us a API, right, where we can customize this like button for our website, and then they provide us with some code that we embed inside our website, and then simultaneously we can access that features of like button on any website or any application. So if I, let's say, give the width as 230, and you can see that this like button is given over here as a preview. And once I click on this get code, they provide us with some codes to include it in our website. This is a JavaScript SDK, and this is an iframe. So if we try to copy paste this iframe and paste it inside a website, you will be able to see a like button like this on that particular place. So this is what a role of widget is, that a widget is created once, used by many developers for various purposes. And in this particular lecture, we are going to design a polling widget. So polling is basically a voting system where users can vote for multiple options that are given to them. For example, if you have a look at the LinkedIn, here you can see I once have written a post asking for a poll. So you can see that this LinkedIn has an in-house voting system where you see the question, you see the options, and when you click on any of the option, you can vote for it. And simultaneously, you can see that it has a bar explaining that, okay, this has 92% of the votes and the rest has 8% of the votes as the share. So that's it. That is indicated by the length of the bar. And you can see the options are having a name, and this is a question and probably a timestamp as well. It says 2 days left, 501 as the vote count, and a hide results button there as well. So this is exactly what we are going to create. But the problem with this widget of LinkedIn is that you cannot reuse this on your application or any of the website, because this is primarily built for LinkedIn only. This is an in-house widget of LinkedIn. But what we are trying to make is, we are trying to make something like this Facebook like button or the share button, where we give developers the ability to reuse this widget across the website. It is independent. Okay, this widget is independent of the environment where it is being used. So this is what the question is all about. This is what we are going to build in this system design question. And the level of this question, as said, is easy. So let us understand the question first. The question states that create a poll widget that enables effortless embedding on websites, including articles, blogs, facilitating website visitors to participate in voting on various options. So the question is pretty straightforward. You have to create a polling widget that can be embedded in websites very easily. It can be included in articles and blogs, and the visitors of that website can participate in voting on the various option that is provided. So what are the explicit requirements? So the widget exhibits the following details: a selection of options for users to vote on. So user once landed on the widget, they can see multiple options on that widget. The most recent count of votes for each option. This information is visible only after the user has casted a vote. So once the user has voted for any item, after that you can see the count of each vote item. Okay, that in the previous LinkedIn example, we saw that the 92% was given as yes, 8% as the no. So this information is only visible only after the user has voted for an option. The provided backend APIs include removal of an item from an existing poll option. The user can unvote an option. Recording a new vote for an existing poll option. The user can vote for an option. Retrieval of all poll results. So this is a generic API where you fetch the polling details of this particular poll, like which option has how many votes. So these, the first two are the action APIs, and this is a get API to fetch the results. Then third requirement states that the ensuring minimal effort for website owners, effortless embedding of the poll widget into the website is a priority. So we have to make sure that Integrating this poll widget into a third-party website or articles or blogs should be very easy, should take minimum effort of the developer. So this is our prime priority. This is the prime priority that we have to look. Then we have to look upon that, okay, user can perform these 3 actions, and then also the widget exhibits these many behaviors. Okay, now once you have understood the questions, you have got the requirements. Now in a system design round, your next move is to ask relevant questions to the interviewers. I'll explain what type of questions you have to ask. For example, if we take this question polling widget as an example, then these are the questions that you have to ask to your interviewer. The first question is, what are the key components most vital aspects? So you have to ask that what are the most vital things that the component should exhibit. So the interview will obviously give you answers once you are asking. So his answer would be, for this example, the ease of embedding the polling widget within the website is critical aspect. So now you verified that the prime focus of creating this widget is that the developer can easily embed this polling widget into their website. Okay, this is a prime focus. So keep this thing in your mind. The second vital aspect is that ensuring a positive user experience for voter is a crucial aspect. So you have to make sure that the UX of this polling widget is also very good. Okay, it should not be a bad user experience. Now the second question, does the widget display personal details like thumbnails of individuals who voted for an option? So the answer is, in this basic version, the widget is designed only to display the vote count without revealing the personal details of the voters. Okay, so we won't be revealing the personal details. We just be revealing only the vote count and the vote percentage. So we are only going to show the vote count and not the personal details of any of the users. So this would be a very basic version of the polling widget. The third question, what is the process of determining the options? Can users contribute additional options? So the answer is, the website owner creates a poll using a separate admin portal where the options are established during the poll creation process and cannot be altered thereafter. So this is one behavior or requirement which you saw. So we won't have to worry about the portal of admin portal that for the owner, because our task is to create the component and not the admin portal. Okay, so we can completely ignore this part. It is not of the concern. The admin portal, we just got to know that the user cannot modify or add more options in the polling. Okay, in the poll, once the poll is created, the options are fixed. No one can alter it, even the owner, not even the users. Okay, is there any limit on the number of options displayed in a widget? So the widget can display a maximum of 6 options or 10 options depending upon the ask of the interview. Okay, so the final question, is a user login required on the page for voting? Okay, this is very crucial question. Okay, so voting is open to everyone regardless of their logged in status. Votes will be recorded and persisted for the same user. Okay, so now we have to determine, okay, so a user can vote without even login. Okay, so there are many edge cases that we have to look into. That, okay, what if someone clicks on the vote button after a page refresh? Okay, will that vote still be there or will it be lost? So what will happen is, if I voted for an item, I refresh the page, I again voted for an item, so I can vote practically infinite number of times on the same page and login is not required. So this is something that we are going to handle in the upcoming steps of this system design question. So in the first step, we got to know the question, we got to know the requirements, we have asked relevant questions to the interviewer. So up till now, we have made a pretty decent impact on the interviewer. Okay, that this candidate is asking good questions, he is aware of the product, he is having clear picture of what he is going to build. Okay, once all of this is completed as a first step, now we have to move to the next step, that is the second step, where we are going to design the structure. We are going to have the various patterns that we are going to follow, and then we have to come up to a final decision. All right, so let us start with the second step. The second step is structure and design. The architecture of the polling widget is carefully crafted to ensure the seamless integration and efficient functionality. Okay, the architecture of this polling widget has to be very crucial, and we have to craft it in a seamless manner that it supports all the requirements that have been given to us in the form of question. So basically, there are two approaches that we can take in creating this widget. The first approach would be an iframe approach, and the second approach will be render within the consumer. Okay, so we have already seen these two examples. The iframe approach is given by Facebook, which we saw. If we go to developers or facebook.com/doc/plugins like button, you can see that they provide us the ability with the iframe approach. And in the LinkedIn example, what we saw, that can be an example of what render within the consumer. Okay, so that was not a iframe, that was not another JavaScript SDK that LinkedIn was using. It was an in-house package that was being used, and it was directly consumed inside the consumer application, inside the LinkedIn website only. So there was no external environment. Okay, it was all LinkedIn's server only. So there are two approaches, and we are going to discuss pros and cons of each of the rendering pattern and which one shall we pick according to the questions. So first, we are going to start with the iframe approach. The iframe approach is very popular. Okay, so let us hear what MDN has to say about iframe. So as per MDN, the iframe HTML element represents a nested browsing context embedding another HTML page into the current one. So iframe, once you import a iframe in your code, what you are telling that, okay, go to facebook.com. For example, if we are importing a Facebook like button, then we are saying that, okay, go to facebook.com website, okay, and pick whatever is being rendered from this src, render that particular content inside my website. Okay, so this what you are saying, that we are rendering a completely different isolated browsing environment into our website. Okay, so the Facebook's environment is completely isolated from your website. So if I go to jscafe.dev, for example, and I try to integrate all this like button over here, for example, so my environment of JS Cafe, my server of JS Cafe would be an isolated environment for the Facebook. So I cannot interfere in whatever this facebook.com is rendering. So it will be a completely independent environment. So whatever code I have in jscafe.dev will not affect whatever is being rendered in facebook.com, because they both are separate servers. Okay, they are not connected in any way. And also, using an iframe in a website can be somewhat risky as well, because you're not sure what the external website is going to render on your website, right? So although this Facebook is a trusted third-party application, they have big brand, it is a known brand, so it is completely safe to use Facebook. But be careful, we have to be careful when you are using an iframe and pointing to some unknown third-party server. Okay, you have to be careful on that part. So coming back to this thing, so we understood what an iframe is. When we when we use an iframe, what we are basically saying in layman terms is that, okay, whatever is being rendered in that src thing, so the src over here is facebook.com. So whatever is being rendered in this URL, render that thing exactly as it is in that particular section that I have defined in an iframe. So that is an iframe. Prominent embeddable widgets like Facebook like button, Twitter's embedded tweets, YouTube embedded videos, and Discuss embedded comments utilize iframes. These iframes essentially function as separate websites solely responsible for rendering the embedded content. Okay, this thing we have already discussed. Now, what are the pros and cons of this iframe approach? So the pros and cons: the appearance of the widget remains unaffected by the CSS of the host website, ensuring its styling remains consistent and independent. We have, since both of the environment of iframe and the consumer application are distinct and they cannot interact with each other, so we can say that whatever CSS global styling you have in the consumer application in our example can be jscafe.dev. So whatever global styling I have over here in the website, So that global styling cannot affect the styles of the content that is being rendered inside the iframe. So we are sure that our widget is going to render same as it is across any third party consumer application. So we are assured on that part. The next pro is the widget's JavaScript environment is also independent of the host website scripts, preventing unpredictable runtime behavior caused by polyfills. All right. So since the environment is completely isolated, so we have discussed that CSS is also isolated. So will be the JavaScript environment will be isolated. So whatever script or JavaScript we will be running on our widget, which we are going to design in a moment. So whatever thing we are going to run, whatever JavaScript we are going to run in the widget, that JavaScript environment cannot be tampered by the external consumer. So my consumer is jscafe.dev. So if I have any polyfill of anything like polyfill of promise.all, for example, and by chance I am using promise.all in my widget API, so the environment of JSCafe will not hamper my widgets environment by any way. So we are also sure that okay, whatever is the expected behavior, that is going to happen. So this is one pro, very good pro as well, and it is very simple to use by developers. We have seen that the Facebook provides the iframe of like button like this as a code. All I need to do is copy this code and directly paste it on my website, and boom, I can see the like button over here. That is all I have to do. So this is very easy. It is copy paste, right? So remember, what was the primal vital aspect? The primal vital aspect was ease of embedding the polling widget within the website is the critical aspect. So we have to keep that in mind, and we can clearly see that it is literally a game of kids. You just have to copy paste the iframe in your website and you are good to render anything on the third party, right? So this is very simple. So think, can render within the consumer approach be better than the iframe approach in ease of integrating the widget? We have to figure that out once we start discussing the render within the consumer approach. So we saw the pros of the iframe, but what are the cons? So a web server is required to host the website that renders the widget. All right. So you need a server that will host this widget somewhere. You cannot like you think by yourself that this particular iframe has a src that is pointing to a domain where this particular widget is hosted. So as a developer of the widget, I need a server where I have to render this host this widget so that anyone else can include this widget as a src. All right. So that is something a con of it, but this is exactly not a con, because once you are creating a widget that is capable of storing the vote counts, it is capable of storing the polling question, the polling items, the vote count of each poll, you need a backend server for that, right? You need a backend server. And once you need a backend server, then I guess you can host that particular website on the same server. All right. So it is actually not a con, and it is not a big deal, because you are anyway going to need a backend server to host the APIs. So why not host the front end as well on there? Okay. So this is a con, but not actually a very big problem. This is a very simple issue which can be solved literally if you have a backend server. And the second con is rendering the website separately can result in slower loading times compared to directly embedding it into the page. So the issue over here is that, let's say if I am using this iframe of Facebook, I have to hit external API of facebook.com, and I'm not sure how much time will this domain respond back with all the widget. Okay, we are making an external API call, and then we are fetching the DOM, we are fetching the response, and then we are rendering it. So it is obviously a time taking step. Okay, had this whole widget been inside our own website, inside my own jscafe.dev, if I had the like buttons code inside my source code of the website, then what I had to do is I only had to include that code into my project, and I don't have to make any network calls to fetch the widget from external source. Okay, so that would have been faster, as compared to rendering the website separately from a third party domain. Okay, so it would be slower, it would be requiring an extra server to host a UI, which can be easily accommodated inside the backend server only. So these are the pros and cons, and I feel that the pros are over dominating the cons, because the first con is not a con, actually it is a very simple thing, and the speed is the issue. But if you have a very healthy server that can easily accommodate a good amount of request, then your consumers of your widget will not face any problem in rendering the widget. Okay, because your servers are really super fast, they receive the request, they send a response very quickly, and your widget is also very light and super optimized. Then this rendering speed can be easily be reduced, and it can be optimized. So I still feel that we still are good with a lot of pros, and the cons can be easily avoided. So that is the pros and cons of it. Due to the isolation, the host website cannot utilize CSS to customize the internal components of the widget. Okay, so next part, this is actually a con. So due to the isolation, so since the environment of widget and your consumer is isolated, as a consumer, as a developer, I may not be able to make or customize or themify that widget according to my JS Cafe. So if I say on my JS Cafe website, I am the consumer of a Facebook like button. Okay, now I cannot make this like button appear white or appear black according to my theme of the website. Okay, it will still appear this bluish white with this particular text like this. Okay, all I can tweak is the various web properties that they have, like basic CSS styles and all, but I cannot themify everything. I don't have complete control on this widget. I can only modify a part of the things that is being actually rendered. I can modify the size and all, but themifying is not, I cannot highly customize it. So it is not highly customizable approach. That is also one con. But as per the question, our prime agenda was the easiness of integrating the widget. That is something I can see clearly with this iframe approach. And we have discussed the live examples as well. We have the Facebook's like button, so you can see that the share button or the like button, they are providing us the two formats. So one is a iframe that we have discussed so far, and but what is this JavaScript SDK thing that we are seeing continuously? Is this also an iframe but another form? So let me tell you that there are two ways to render an iframe in a page. One is a dynamic JS and one is a direct embed. Direct embed is this particular approach in the iframe where you can copy paste the iframe tag and paste it. This is a direct embed approach. And another approach is a dynamic JS. Dynamic JS is something like this, where you will be given a div, a root tag, then you have a script tag to import, and this is the place where you can, wherever you want the plugin to appear. So it only has one advantage over it. So the JavaScript approach, the dynamic JS approach, obviously allows customizations for the iframe rendering, example theme size, based on the environment if needed, while the iframe approach is simpler but less flexible. So you can see that this particular code where we are having various data attributes like data weight, data layout, data action, data size, data share, and you can introduce your own new data attributes as well as your widget grows. What this is providing us with is that we can actually, when the website is rendering, when your website is rendering, you can actually tweak these values with JavaScript. By tweaking, what I mean is you have a JavaScript code that runs on the load of the application. Okay, for example, so what you need is JavaScript onload call function. So we have a onload event, not this. Where is MDN? Window load event, right? So window load event is fired when the whole page content has loaded, including all dependent values. All right. So what you can do is you can have a event listener that listens for this load event. Once this is fired, means that your website has loaded. Now you have the height and width and screen size and the rendering environment, the browser in which it is rendered. You have all that information. You can access to that information, and then what you have to do is you have to access to this class, or you can introduce an ID also, like FB root or FB like class. And then what you have to do is you have to update the data attributes from the JavaScript, and this will be dynamic. So the widget would be rendered dynamically across various environment, and you can also themify it. So it provides us the flexibility of themifying the widget, but again you need to have a script tag that will make a script call and other stuffs. So, but again, this is not something easy as compared to iframe, because we have to place first of all this particular code where we want to render our like button or the widget, and then we have to again paste this code somewhere else. So there is an extra effort, and also the developer has to make account for all these data attributes as well. In the JavaScript they have to write logic to calculate the values and other stuffs. So this is a little complex thing, but this iframe is just copy paste, and still I think this iframe approach will be better than the dynamic JS approach, because in the question there was no ask to have a flexibility. It was only that our prime focus is that ease of integrating, so it can be integrated easily. That is our prime ask. So if we are going with iframe approach, if only, then we are going to use a direct embed approach instead of a dynamic JS approach. That is one thing. Now we have discussed the iframe approach out of the two rendering approaches. Now we have to discuss the rendering within the consumer approach. So rendering within the consumer. So here you will be creating a component that any developer can import in their project. Developer has the freedom to modify a code. So think of all the packages that you see on the npm. So if we go to npm, and so whatever packages you see on this npm, okay, so for example, if I see npm carousel, angular, or we are React lovers, so we'll go with React. So npm responsive carousel, so this is an npm package. Okay, they are having the usage, and they are having all of the source code available on a GitHub like this, on a repository. So what I am saying, render within the consumer. So if you are importing, let's say you are working on a React project and you are importing a npm package. So what exactly you are doing? You are having that particular widget as a source code inside the node modules of your own project. You are not making any external API call to fetch the widget code. Okay, understand this thing. In iframe, what we were doing is, in iframe we were making an external API call to fetch the widget, but with render within the consumer, we are directly installing that package in our project, and we are directly importing that inside our component or src file, wherever you want it. So we have the freedom of modifying their code. All I can do, instead of node modules, I can copy all that package into a separate folder in my src, and all I have to do is I have to reference to that package instead of node modules. And as a developer, I can tweak that package according to my needs, and my widget would be something else. All right, so I have the flexibility. The only con is that since you are having this package in someone else's environment, so all of the pros that we had for iframe will become a con over here, because again, if I had a promise, if I have polyfill of anything, that is heavily going to affect the computation, the logics of that widget. The css can also be modified, everything. And the only pro is that since the widget is present in the same server, it would be faster to load. Okay, so again, but this is not the case that we want for our question, because the question is stated that we want to make this widget seamlessly integratable. It has to be very easy to use, and with this render within the consumer, what we have to do is, first of all, either we have to host it on a CDN or we have to host it as an npm package. Then we have to install it and we have to bring it into our environment, and then we have to perform other stuffs. So these are the two approaches for a poll widget. And so what are the final decisions that we have to make? So which render pattern are we choosing? Obviously, we are using the iframe pattern as the assurance of widget to render accurately, and it is easier to serve. How are you going to render an iframe? We are going to use the direct embed because it is the easiest to use and it fits exactly to the needs of the question. So in the step 2, we heavily discussed what will be the structure, what will be the rendering design pattern that we are going to use, and so far we have a concrete understanding. Okay, so we have a direction to move now. Okay, earlier we had a question, we had the requirements. Now based on the rendering approach, we decided, okay, we have this a path that we have to follow, is that we are going to render an iframe, that too with a direct embed. So we have a clarity in mind. Okay, this our widget is going to look something like this, a iframe with this, and it has a src, and then we are going to host that widget on a server, and we are going to create a component and all. So we have all of things aligned now. We can visualize, okay, what we are going to make, and this becomes very interesting as well. So coming on to the next step, is the architecture diagram. This is very important, and you have to also make this and show this to the interviewer also. So the overall architecture is that we have a widget website. Okay, this big container is a widget website. This widget website will be storing our widget. Okay, this particular widget is a combination of two components. One is a UI, that is a visual thing, the component css stylings, and one is the store is basically the logics. Okay, and then apart from the widget website, we are having two entities. One is the backend and one is the app server. So app server is basically hosting this widget website, and the backend is a server that is hosting our backend APIs. So the store, the logic of the widget, is directly interacting with the backend API. You can see this over here. These arrows. Okay, this is a two-way arrow. So the store is interacting with the backend API two ways. It is making a request and receiving request. That is what I wanted to make highlight over here. And the app server is pointing to the whole widget website, which means that the app server is hosting our website. And the store and the UI are also interacting with each other. The UI is accessing the results from the store, and the store is sending the results to the UI. And also, these are the component definitions. The website widget, the website that embeds the web widget as an iframe. App server, responsible for rendering the widget UI as a website by serving the necessary HTML, CSS, and JavaScript. The backend handles the retrieval of the poll results, JSON data for the widget, and accepts new polls. Store manages data interaction with the API server and stores data for the UI. And the UI is the user interface component displaying the poll options. So this is the architecture diagram. It is very straightforward. All right, now let us have a look at the backend API model. In the backend API model, the interviewer is going to ask that, okay, all right, we have decided the rendering pattern, we have the questions. Now, what will be the backend response would look like and how we are going to consume it? So we can count the basic entities that we are going to need from the backend API on the fingers itself. That first of all, we need the polling question, at what time it was created or what time it was last updated. Then the total vote counts that have been put up. Then we have an array of individual vote items. That inside the individual vote item, there would be a unique ID, the polling name. Okay. Then you have the number of votes, and has user selected this vote or not. So this flag is basically being used that if you want to specifically highlight the user's vote as a separate UI all of it. So That is one flag, and this is all what you will be needed for this backend API. So we can see that this is the JSON response that we are going to expect from the backend. It has a state object that is containing all the necessary data for this particular poll, and you can see the timestamp. Timestamp is the time at which the poll was last updated. The vote count. Vote count is basically it stores the total votes in the system that has been put so far. Inquiry is the poll question. For example, it is which is your favorite YouTube channel is the question of the poll, and the choices is an array of poll items. Each poll item has a identifier. It is a unique identifier. Then it has the name. Name is basically the name of the poll. So it is the name of the poll, right? So like my options are JS Cafe, Momo's Cafe, and Pizza Cafe. So these are all the name of the YouTube channels, and I have to pick out of these three. So these are the names, and the votes. Votes represents the vote count for a particular channel, and is selected is a Boolean flag that states that did the user voted for this item or not. All right. So we have defined our basic, JSON response from the backend API. We have defined definition of the backend API. We have now we are done with this backend API model thing. Now we have to jump to the next step. That is the embed API model. Embed API model is the part where you will be deciding what would be the model of the iframe tag that you would be exposing for your consumers. All right. So we have this particular iframe tag that I am expecting to be created. This iframe tag would contain an SRC that would point to the widget URL where it is hosted, and this SRC would also provide the poll identifier. It is a unique ID that can render different polls according to their ID. Okay. This is the external styles that I can pass to an iframe. So overflow hidden is one of the styles that I can pass. I can pass the title of the iframe that widget is served for front-end developers or something like that. Then there is a frame border that how much border I want on this iframe. Then you want to enable scrolling or not. Then what should be the height, what should be the width, and so on. So these are all basic things that we are going to expect inside a iframe tag, and this would be the embed API model. Now comes the main part, that is a component design. So we have to design the API for the component that is going to be rendered on this particular URL, jscafewidget.com/embed. Although this is not any valid URL, this doesn't exist. I created it just for a reference, but yeah. So component API is over here, and this component API that we are going to design would look something like this. And let us try to understand. This is the component definition for this, and this is the component that we are going to latch onto it. So as those who have already seen my videos on the YouTube channel, they can easily recognize what design pattern we are actually using in this poll widget. So poll widget, poll options, poll items are being fetched from a single component. So this becomes a React compound pattern. I already have a video on the YouTube channel for it. So this is a compound pattern where poll widget is the the main component. It is having various props that is it is accepting. We are going to discuss on this, and it also has poll options. Poll options is a wrapper basically for all the poll items, and then we are iterating over the props.choices.map, and we are having a poll item over here, and this particular poll item component is rendering individual polling option polling choice. All right, so let us discuss the component definition. So poll widget URL is having a submit URL prop. This is the API endpoint of the backend which we want to hit from the front end, and from this is the only API from where we are going to fetch all the data related to polls, and we also call this API for all the actions when the user votes, when the user unvotes. And we are also passing the timestamp to this poll widget so that it can render the timestamp and show that okay, it was created 1 day ago, 2 day ago, or it was last updated at 5:30 p.m. or whatsoever. And we are passing the total vote count so that it can be displayed on the UI. Then we are also passing the question that can be again displayed on the UI because it is a parent container. So all of the things that are relevant only to the widget at a high level, that is widget question, widget polling question, polling total count, the last updated, and so these are all the visuals that are going to be, that is widget specific and not the polling item specific. All right. So we have passed all these props, and submit URL is something that is related to each widget, each poll. Okay, this is the API that we are going to call. And then we have a poll options that is again coming from the single component. You have to explain it to the interviewer that this is a React compound pattern. All right. So I can take you to YouTube channel and say a search for JS Cafe React compound pattern, and you can watch this video and you can see that what is a React compound pattern and how we are using it. So React, to sum up, like multiple components come up together to serve a common functionality, as I am saying in the video. And there is one common tag. So there's one common tag, and these are all the multiple tags that are again coming from the same component. All right. So this poll options is a wrapper for all the poll items. Then this poll options wrapper, inside it, we are iterating over the props.choices.map. Why props.choices.map? Because we already discussed in the backend API that the items are going to be present inside the choices key. So choices would be an array. So this we are going to pass state as a prop. So prop.choices, this is an array. So we are going to iterate over the array via a map, and we are going to return a poll item component. This poll item component will receive all the configurations that are related to a poll item, to a particular choice. So we are passing the key as poll.identifier. The count of that particular vote item is poll.votes. The label is poll.name. Label is something like the name of the item. Like in the previous API, we saw that JS Cafe was one of the option. The Momos Cafe was one of the option. The Pizza Cafe was one of the option. So these are all the names of the polls. So poll items has a name. So that is being passed from over here. So it has a name. Then we are having two action events. So one is on unvote and on vote. So user can either vote on an option, or if you want to unvote it, he can again tap on the same polling item and the vote is unvoted. All right. So these are all the two action items, and we are assuming that we are having a remove vote function that is accepting the identifier of the poll. And over here also it is a submit vote function that is accepting the poll identifier, and it has a prop is selected that is again coming from a boolean prop poll.user selected. This poll.user selected is for the case that did the user voted for this item or not, so that if it is true, then we can highlight that particular poll item differently so that user can identify, oh, this was the item I voted for, it is, and it is having these many votes. And also once this is true or false, then we can also show the polling data as well, because using this prop, like if this becomes true, then we can show all the details. Okay, these were the vote count for each of the items, and these were the users who have voted for this. So these are all the details of the component, and we have discussed the component definition. And this part is very crucial because here we utilize the React compound pattern, and this is actually very reusable and customizable. All right. So Today we have poll option, then in future you have some another UI that we want to import, then you have to keep the poll widget as it is, and all you need to change is the poll options and the poll items. Okay, so I'm assuming that you have watched that compound pattern video and you are comfortable with this compound pattern. If not, then you can pause the video and go to this particular video on YouTube and watch it, and then come back to this. All right, so we have discussed all the component definition for the poll. We have designed our component, and now comes a very crucial part that we have to deep dive into the few very minute yet very important details of this particular questions. We are having certain edge cases, and we have to identify, okay, this is how we are going to handle these cases. So one is the anonymity of the user, the other part is the rendering the bars, the other part is the loading state, and then is the biasing. So these are all the aspects that we have to handle, and you interviewer is also expecting us to talk about these edge cases as well. So the first part is the anonymity. The anonymity means that, as we already discussed in the question, that user does not have to log in order to vote. So this creates that, okay, I can refresh the page again, I can vote again. Then how I'm going to keep a track that, okay, this user has already voted or not? So if I refresh a page, my vote is gone, right? Then what's the point of voting if I am not able to see how my poll is doing with my votes? So to ensure persistent voting across sessions without requiring user login, we can use cookies to generate unique user ID. We store that cookies onto the user system and we try to fetch it. And based on that cookie, we determine, okay, this user has voted for this particular option. That is one case. So this allows the poll widget website to track the user selected options and prevent multiple votes. All right. However, user can bypass this by using different browser or devices. Let's say I voted once from my laptop, I can vote from my mobile, I can vote from my tablet, and so on. And to mitigate this abuse, user has to log in, and authentication becomes necessary at this particular point. So we want the user to log in if we want to handle these bypass cases. All right, there is no other case than that. But to handle this abuse at certain extent, we can use cookies to store it on the user's system on the browser, and we can fetch that, okay, this was the poll that user has voted for, and this was the current count that is presently there. Next is the render bar. So currently we can have two types of bars of the widget. Okay, the polling bars for the widget. So that can be a static width. If there is no animation on the bars, then we can use the styling of the bars of the poll items as something like this. We can provide an inline style of width 40% or width 30%, depending upon the depending upon the numbers of votes that is being presently there. But the part is that we had to use an inline style because these numbers can change dynamically from the user's point of view. This is okay for the case where we are not having any animations, and we already know that we cannot animate width properties because they are non-performant. And let's say if the use case is that you have to animate your widget, there's a case that, okay, once the user clicks on a poll item, the poll bars animate to certain widths. Okay, you have to show animations. Then you cannot animate this width property. And why we cannot animate the width property is because that these are non-performant. And I have also linked an article from Medium where you can see that low performance CSS transition and some alternatives and whys. Hows and whys are already there inside this article. You can read them. To cut the long story short, you should never animate width property or the height property, or animate top, left, right, or bottom properties. The best way to animate anything is using the transform properties. Like you can translate, you can scale. So these, and you can change the opacity. So these are all the performant properties that are suitable for the animation. So instead of width, we can use a transform, and we can use scale X for a property of 80% or 10%, depending upon the value that is coming from the API. So we have handled the two cases. One is the user anonymity. We have handled, okay, the static and the animating cases of the progress bars, of the poll bars. And then we have the loading state. So loading state is that when the widget is currently loading, then what are you going to show? So instead of displaying a spinner, so you see that a spinner is loading like this in a circle, we can show a shimmer loading effect, and this effect provides a visually pleasing animation that indicates that loading process to the users. So I can show you what a shimmer loading is. Shimmer loading examples. So if you can see this over here, this is a shimmer loading, that okay, something is loading in a grayish thing and something got loaded eventually, right? So this is a shimmer loading effect. I may have some better examples. Let it go to Flutter, and you can see that okay, they have very nice video over here. You can see that it is animating, and after the animation finishes, we have everything present over here. So this is the shimmer loading effect. Nowadays, the circular spinners are little outdated, and this is the this is very great loading effect that you can implement. All right, we talked about the loading and then about the bias. So to minimize the bias, it is advisable to hide the poll results until the user has cast their vote. This approach prevents the displayed results from influencing user decision and encourages them to vote based on their personal preference and rather than being influenced by the current outcome. So again, we don't have to show the outcome, the current polling status to the user until and unless he has casted a vote. So because this will prevent a bias from it. All right. So we have a deep dived into the poll widget. We have handled four cases, four important cases, and these are the crucial ones. And next part is talking about the performance and the optimizations, and this would be the final step inside in our system design question. So for the solution, we are having we are having four performance and optimization keynotes. So the first performance optimization we can have is the server side rendering. So to optimize the rendering results, it is recommended to have the server API return tabulated results instead of raw data. This approach eliminates the need for the client to perform any result tabulation, resulting on the faster rendering of the results. So what we are saying that instead of making the fetch call on the load of the website, what we can do is we can perform a server side rendering of this widget of this thing, because what will happen is that let's say your website is loading, then we have to make you have to make API calls and then you have to fetch the data. But all with server side rendering, all of that HTML DOM and other thing will be computed pre-hand and they will be served from your server. So we are saving the cost of making network calls on the load of the website on the client itself. Instead, we are moving that efforts to the backend. So server side rendering will help us optimize the rendering results. Obviously, the next optimization is the optimistic updates. So this is a new like this. I am assuming that this would be a new concept for you. You might be hearing it for the first time, but this is a very crucial optimization that most of the websites and most of the popular products are doing. So let us try to see what an optimistic update is. So you can go to this website to understand deeply what an optimistic update is, but I am going to show you this optimistic thing via an example. So what we are seeing is we are having optimistic updates. So for example, we are having this star widget. Okay, we are having this star widget over here, and the expectation is that when I click on this star, the backend API should be notified immediately. Okay, I have hit I have updated the star rating of some item. Now there are two cases emerging from this. One is that after clicking on this particular thing, I wait for the backend API to get resolved. If the backend API gets resolved, then only I am making this 2-star as a 3-star. Okay. Otherwise, I am going to keep it as 2-star. Then what is the scenario over here? Is it after clicking on the 4th star, I am waiting for the backend API to confirm whether the request was successfully noted or not, that I am changing the rating from 2-star to 4-star. Now the catch is that the UI has to wait for the API call to get finished. Then it has to receive the response and okay, identify, okay, the response was positive or negative, there was some error, or was it successfully noted. So to handle that, you have to wait for a lot of time for this UI to come into effect, and that degrades the user experience. But on when we are using this optimized updates approach, what we are doing is we are updating the user state, the state of the application, even before we get to know the response from the API. What we do is, let's suppose I click on the 4-star, it got updated, and on the loading you see that it was loading, having a loading state stating that a API call is happening. But what I was seeing, that the state of the application got immediately updated to 4 stars, and even if the API failed, it got rolled back to 2 stars rating. So this is very optimized thing, right? This is very optimized version. Same is the case applied to the polling system. Imagine these are the various polls. We are having 5 polls, and you voted for the second poll. Now in your mind you want to change the poll to 4. Now will you wait for the API call to happen and then you will wait for the UI to come into effect? No, right? Users are having the least patience when they are interacting with the websites. So what I will do as a developer, I will make an optimistic update that okay, I was selecting, for example, if we have a look at the API, we are having 3 options to vote for. We are having JS Cafe, we are having Momos Cafe, we are having Pizza Cafe. Now as a user, I voted for Pizza Cafe first. Now my mind changed, and now I want to vote for JS Cafe, right? So after clicking on the vote item of JS Cafe, in the optimized optimistic updates, the poll will be automatically be changed to JS Cafe, and this Pizza Cafe will get unvoted. And simultaneously we will show a spinning loader saying that okay, something is happening in the background, and let's say if the API was successful, then we don't have to do anything, we are going to keep the state as it is. But if the API failed, then we are going to roll back the user's vote back to Pizza Cafe. So this is the optimized update. And trust me, if you talk about optimistic updates out in your interview, then like your interviewer will get extremely happy and extremely impressed. So talk about optimistic update. Try to use optimistic updates as many times it is possible. Although it is very tricky to implement, it is not that easy, but this is what we are expecting in a system design round. You want to implement the best optimization, the best techniques for a particular problem that is being given to you, and optimistic update is one of the greatest concept that you can implement in a system design. So let me serve you the definition. Optimistic update is a technique where the browser displays the new UI state after sending a server request before receiving a response. By utilizing the current result during the initial load, the client can increment the newly voted option and calculate the updated bar ratios on the client itself. This approach prevents the real-time visual feedback to the users, enhancing the user experience without the need to wait for the server confirmation. Right? So this is the optimistic update, and trust me, the chances of API failures are usually very less. So most of the time you will have the optimistic updates on the client end only. Scalability. Given the limited number of options, maximum 6 or 10, the risk of generating a large DOM size is low. However, if needed, then we are going to definitely need a virtualized list within a container of limited height. This way, only the visible options are rendered, preventing excessive component height and improving performance. So virtual list is something that whatever, let's suppose we have a long list, right? We have a long list of items over here. So what Miro board should be doing is that whatever content is present inside my viewport, render that item only, and whatever is present outside my viewport, you do not render it. You kind of delete it from the DOM or something. So this way, what I am doing is I am saving a lot of performance heavy task. Right, my website will get optimized. It will get performant. So talk about a virtual list when you are rendering a long list of items. Okay, this way it will be a very cost effective and very performant. Accessibilities. So implementing ARIA attributes and role enhances the accessibility for the poll widget, ensuring an inclusive experience for the reader users. So we have to also account the accessibility things. Like, let's suppose if your polling widget is being used by a blind person, right? So by default they are using the screen readers that speaks out the ARIA labels. Okay, so to ensure the accessibility of the screen reader user, it is important to utilize the ARIA attributes. Use ARIA label, title, ARIA described by to provide information about the option name, number of votes, percentage if they are not visually displayed. All right. So to dynamically announce any live update, you can use ARIA Live to notify the screen users of the result value. For polls, only one option selected, assign role radio group to the container and use role radio to each option, enabling proper navigation and selection of the screen reader to the users. Then keyboard interactions. When rendering the poll result, it is generally common to use button elements. However, it is specific if there is a specific reason that you are not able to use the button elements, then use a div element. Then but you should also pass the tab index and the role button attributes, because the JavaScript is or the screen readers are not going to think, okay, this particular div element is clickable or not, unless you have a particular element type on the DOM. Okay, so if an item is clickable, the screen reader is expecting it to be a button and not a div, because div by default are assumed non-clickable. So if you're having any click action item, then use buttons. And if you by chance, if we had to any case by use divs, then you have to use tab index and role as button, so that if the user is navigating via the keyboard or it is being used by a blind person by a screen reader, they can efficiently navigate through your widget. This ensures proper accessibility and allows user to interact with options using the keyboard navigation. All right, so we have deep dived completely into the poll widget system design, and we solved this question in a very optimized way. What we discussed so far was the question, the requirement, the question that you have to ask to the interviewer. Then we designed a structure, the rendering pattern, when we discussed why we have choosing iframe approach instead of the render within the consumer approach. Then we create a super attractive architecture diagram, the component definition. Then we discussed on the backend API model of this whole polling widget. We discussed each component of the backend API. We also created the embed API for the iframe, followed by the component API, where we heavily stressed on the compound pattern, and we made it highly reusable and customizable. Then we discussed on the edge cases of the parts that are serving the critical aspects of the application. Then we talked heavily on the performance and optimization and all the techniques that are crucial for this polling widget question. So I hope you like this one. If you had any questions, then you can drop a message to me on the Discord or on LinkedIn or on Instagram as well. This was all in this particular lecture. See you in the next one.